at Petronas Research Sdn Berhad. I'm a process chemist. My background is chemistry, and I've been working in the oil and gas and energy industry for almost 13 years now. So, number one, I would like to extend my gratitude to UM, and especially Dr. Mugunda for inviting me to actually speak and share with everyone today about the applications of chromatography. Since I am from the oil and gas industry, so I will be focusing more of the applications of chromatography, especially the GC technology, towards how we actually use it in the oil and gas fields. Um, but before I start, I would also like to take this opportunity to congratulate University Malaya for being listed as one of the top 20 universities in Southeast Asia, or is it Asia? So well done there. For your information, I am also ex-alumni of UM. I was exactly in where you were sitting 5 years back. So I took this course 5 years ago, but back then it was taught by Dr. Tay. So that's a little bit about me, and let's start with the presentation.
Thank you so much, Mr. Sharizal, for the compliment. You may start. Yeah.
Okay.
Okay.
So can we have the next slide, Doctor?
Okay, sure.
Yeah. So this is basically the content of the presentation. There are mainly three sections which I will go through, but the entire purpose of this presentation is to really give you a feel or an idea of how chromatography is actually used in industry. So it's a very powerful tool, chromatography, and it is actually one of the tools that we use greatly in the arsenal of analysis that we actually have. So can I have the next slide? So let's start with the introduction. Next slide, please. So before we jump into the presentation, these are some of the buzzwords that I could actually come up with when I think about chromatography. So I believe some of the points here would be very close to your heart, since you've already taken the course for, I believe, a few weeks or months now. So I will not actually cover the theory per se, because I believe that has already been covered in detail. So I will be more parting knowledge about how does chromatography actually make the oil and gas industry work, and actually how does chromatography actually contribute towards how chemists actually perform their jobs on a daily task. Can I have the next slide, please? Okay, so let's start with the basic definition. What is chromatography? So chromatography is basically a process of separating components or solids of a mixture. The key word here is mixture. So if you have a mixture, therefore it is actually made up of a few components. So given the right properties that you can exploit, you are able to actually separate these components into various subgroups, and that is achieved through chromatography. So let's look at the definition. The definition right here really says a lot about chromatography. So let's have a read of that. So it says here it's an important analytical technique that enables separation, identification, and purification of components of a mixture for qualitative or quantitative analysis. So most of the time, and even I believe in your own experience, you would actually have used a certain type of chromatographic approach or method, and you can see that it is actually mainly used in industry. In my case, it's mainly used for qualitative analysis, basically to quantify and also to separate different compounds and that we actually need to measure. So types of chromatography, there's paper, thin layer, column, gas, and liquid. So the gas and liquid chromatography here is mainly a little bit more complicated than the simpler paper, thin layer, column chromatography. Of which I believe the paper chromatography, if back in school days, we used to do that test, and using gas and liquid chromatography as well in industry, it opens up a whole new area or to actually explore, not just from a routine analytical standpoint, but also from an R&D standpoint as well. So can I have the next slide, please? Okay, so big question here. What type of chromatography is most used in the oil and gas or energy industry? The answer to that is mainly there's two types of GC approaches that we are, normally use. The most widely and most popular being gas chromatography, and we also use to a certain extent LC or liquid chromatography or HPLC. So the reason why gas chromatography is mainly used in the oil and gas industry, because oil and gas, right? The components of oil and gas is mainly hydrocarbons. So you have the carbons and you have the hydrogens, and mainly they are volatile. So one of the properties that we exploit for these particular samples, which is hydrocarbon, is that they're volatile. So that's why we use GC as a tool to actually identify what are the components of the mixture in a particular hydrocarbon system. So most of the time, the GCs that we have are the normal common GCs. We have GCs which actually has a very basic setup where you have a heated injector, you have a oven where it houses the column. It can be a pack column or capillary column. And also it has a detector. So the detector can be FID. Most commonly is FID since it's hydrocarbons. We have TCD detectors, and to a certain extent, if in R&D where what I'm doing, most of the GC systems we have are actually hyphenated with other forms of separation or post-separation systems. We have 2D GCs, or basically it's just two columns put back to back together. When we have GCMS, we have TOF, we have GCs in other configurations as well. Some can be very simple, some can be very complicated. And for liquid chromatography, it is also used quite widely in the oil and gas industry, mainly because when we need to look into higher molecular compounds, which really can't be applied into a GC system. So we would actually use a HPLC system, for example. So we use this for produced water samples when we want to look into contaminants in water, for example, just before we actually discharge processed water. So there's a lot of specifications that we have to look at and we have to analyze prior to discharge. Can I have the next slide, please? Okay, so really quick here. Um, what if you obtain an unknown sample? Most of the samples that we get in or we analyze in the oil and gas industry is mainly what we call routine samples. So if you were to be a chemist that works at a refinery or a gas plant, the type of samples that you'll be looking at or be analyzing from a day-to-day basis would be samples that are coming from the process streams. Process streams meaning that if you can imagine, if the refinery produces natural gas or liquefied petroleum gas, which is actually used for cooking, LPG, or LNG, which is liquefied natural gas. So you'll be actually analyzing these samples on a daily basis. Therefore, you would actually know what is the parameters of testing. You will know what is the composition, and anything out of the extraordinary. For example, you get any ghost peaks or you get any weird looking peaks, that you would definitely know that there might be a problem either with contamination or the process, right? But if you do get certain samples under investigative testing, in my case, for example, it may be in R&D or when we do process shutdowns where we need to shut down the plant and we take samples from areas where contamination is prone. So we do get unknown samples. So these are some of the steps that we actually take to actually analyze these samples and really trying to figure out what form of um, chromatography to use. So if you get an unknown sample, normally what we do is we ask ourselves, is it a gas or liquid? Is it a volatile liquid? If it's volatile, most probably that we can actually subject it to GC. Is it organic or inorganic? That's also a very important question to ask. Then you can actually run a CHNOS or even an FDIR and determine if it's an organic or inorganic compound. CHNS analysis would actually tell you that. So next question, if it is a organic compound, can it be vaporized? So if vaporization normally takes place at a high temperature, in this case, let's say it's 450 degrees C, the entire sample matrix should be vaporized at this phase. So at that condition, so hence you can actually use the GC. But what if the compounds are comprising of really, really heavy or really high molecular weight compounds, right? And to a certain extent, they could be soluble in particular mobile phase. So then the use of a LC or HPLC can also be used. But there is also another form of chromatography, which is what we call ion chromatography. So that is mainly reserved for inorganic compounds, where we want to separate or we want to identify specific cations and anions in the particle sample. So can I have the next slide, please? So let's look into what is the application of GC in the oil and gas industry. Can I have the next slide, please? Okay, so overall, gas chromatography per se has a huge application in the oil and gas industry. So we use it for everything and anything under the sun, technically. So mainly it's used for hydrocarbon compositional analysis. So we use it to determine what are the constituents that make up certain hydrocarbon mixtures, for example, naphtha, or we look into the petrol that you pump into your car. Yeah. So when we put it into a GC, you can see that various peaks at the different retention times actually produce a significant or a specific fingerprint for a particular product. So we also use that to actually determine the quality of the fuels that we produce or the products that we produce from the refinery. We also look into contaminants and compositional analysis of a particular sample. The raw hydrocarbons that actually come from the reservoir is actually contaminated with specific types of contaminants such as hydrogen sulfide, CO2, and a certain extent also mercury. So chromatography opportunity or ability to actually screen and identify and quantify these kinds of contaminants within the sample. We also use it for appraisal. This is normally done by the geochemists, we call them. So they would actually collect a sample from deep down in the earth. That's before we actually start drilling for wells, and we actually measure the compositional and composition of the samples, for example, to determine if that particular area has oil and gas or not. Routine QA/QC is also very important to be conducted in the oil and gas industry, which GC is also used for. Spot checks, quality checks, which is also done quite often to ensure that the quality of the products are tip top and also on specification, and also in R&D. So R&D we use, it's a bit more. It gets more interesting when you look into GC application in R&D because you start to use different types or variations of GCs. Can I have the next slide, please? So let's look into what are the different types of samples that gas chromatography can be used for in the oil and gas industry. So first of all, most importantly is to identify what kind of sample that you are going to analyze. Again, the samples have to be able to be vaporized or volatilized in a heated environment. They should not be too heavy because if they are too heavy, they might drop out or condense when they move through the chromatographic setup. Um, the type of samples that we actually analyze range from the raw hydrocarbons, which is actually crude oil. Everything starts with crude oil, and we also do what we call crude oil fingerprinting. So it's a method that we use to actually apply chromatography, in this case HTGC, for example, high temperature gas chromatography, to actually produce a chromatogram or fingerprint of specific crude oils that can actually be determinative of the quality or the source of a particular crude. Then we also have processed products such as liquid hydrocarbon, naphtha, the fuel that you add to your car, we have, which is called Primax in the case of Petronas. We also have Jet A1, which is actually jet fuel. So these are all the types of hydrocarbons that can be really analyzed using GC and to determine their quality and also the compositional aspects of that. And to a certain extent, we also have products in the form of gas, which is like LPG, gas that you use at home to cook, and also what we call LNG. LNG is basically liquefied natural gas comprising of mainly C1 or methane that we actually sell. So we use the GC to actually, quantify and also do QA/QC for these kind of samples as well. Can I have the next slide, please? So let's look at the hydrocarbon value chain. So basically, what the hydrocarbon value chain means is that from the point of origin where the oil or the hydrocarbon is being extracted, which is in our case in Peninsular Malaysia and also East Malaysia. East and West Malaysia is actually offshore. So most of the fuels that we get, the hydrocarbons that we get, is actually offshore. So you can actually find a GC, gas chromatography device on an offshore platform. Some of these platforms are equipped with GCs to conduct quality checks, for example, especially when they're actually digging for a new well. When they collect a sample, they need to continuously check the quality of the gas that's coming out. So it's done for appraisal and to a certain extent also to detect contaminants, because most of the time the contaminants is very high when we start to take it out from the reservoir. So that's when a cocktail of mixtures of gas, oil, and also other forms of contaminants like hydrogen sulfide, CO2 actually co-migrates together with the hydrocarbon column to the top side. Um, and when we do the transportation of the oil or the hydrocarbons, condensate or natural gas from the platform to the onshore terminal, for example, it can be either delivered through a pipeline or through large ships. And these ships also have GCs on them, again for a safe purpose, to actually test the samples, to ensure the quality of the samples, and to ensure and also to measure the level of contamination, because this contamination, we use technology to actually remove these contaminants, such as absorbent technology, membrane separation technology, really to purify the hydrocarbons, to ensure that these contaminants are very low in concentration prior to actually processing them at the refinery. So when we reach the oil refinery, again, there are also GCs there as well, a lot of GCs there. But the GCs there are mainly used for quality control and quality assurance applications. Quality control meaning to say we produce intermediate products. For example, when it goes through the distillation column, you'll get the different types of fractionates. You get kerosene, you get naphtha, yeah, you get natural gas, and these samples or these components will actually get further processed. So in between these processes, they have checkpoints. So that's where the quality control comes in. And at the end of the line, where before we actually sell these products, that's where quality assurance comes in. So you will have a chemist, um, a registered chemist, which will need to sign off certain documents. So we run a series of tests for a particular product. For example, like the fuel that we actually pump into our car, it goes through at least 15 types of different tests. And all that test has to meet specifications, one of which actually uses a GC. And that needs to be signed off by the chemist in charge, so that it meets the quality standards. Can I have the next slide, please? Okay, so just to make things a little bit more interesting, uh, the Petronas AMG F1 team, this is actually our F1. We work together with the Petronas AMG team, which we develop different type of fuels and also different types of lubricating fluids for the F1 team. And on the team itself, they would actually move from one continent to continent to actually race. So it's the F1 race. So there is a team that actually goes together with the F1 team, which we call a track side fluid engineer or trackside engineer, and their job is mainly to test the quality of the fluids that we feed into the vehicles. In the picture here, you can see the two cars, of which is driven by our F1 drivers, the very famous Lewis Hamilton and also Bottas. So pictured there is actually Lewis Hamilton looking at a sample of fuel. And in the picture below, you can see this lady here actually using a GC to actually analyze the sample. So um, GC is also very important in F1, so to say, in motorsport, especially to determine the type and quality of the fuel that we actually put into these F1 cars. So there are specifications by the FIA, which is the body that regulates F1 racing, that these fuels needs to meet certain standards in order to be in the race. So can I have the next slide, please? Okay. This is a very interesting question, if I do say so myself. What does a 20-story high distillation tower have in common with a gas chromatography column? So if you've ever seen or ever learned about fractional distillation, I think this is Form 5 science information right here. So if you were able to look and see a real distillation column, it's it's huge, it's massive. So it's as high as a 20 to 25-story building. I've ever climbed one of these before, and it's not a good experience because you're so high off the ground that when you look down, you get pretty scared because I'm scared of heights. So it was a very interesting experience for me. But nevertheless, the point that I'm trying to make here is that both of them perform a separation. The difference is that the distillation column is not or does not have the resolution or the capability to resolve as much fractions as compared to, for example, a capillary column. So this is actually an effect of what we call theoretical plates. I believe you've already covered the subject of theoretical plate. So you can imagine that that a huge distillation column has between 20 to 30 theoretical plates to actually separate the different fractions of hydrocarbon. So the crude oil can be fractionated into fuel oil, lubricating oil, diesel, kerosene, naphtha, gasoline, and petrol. But when you look into the capillary columns, which are much smaller, but and also relatively quite long, they have much higher theoretical plate values, and hence giving them more a capability to actually resolve a particular mixture into their native compounds. So basically, yeah, they have theoretical plates. So the theoretical plates is actually what is able to actually give these systems the ability to resolve those mixtures into separate compounds. So can I have the next slide, please? I hope I'm not going too fast because I do have a limited time to cover everything, and I'm going as fast as I can. So if you have any questions, just ask, and I'll be more than happy to answer. So
It's okay,
let's.
Mr. Sharizal. You can take your time. No problem. No,
Oh,
no, no,
okay,
no. Yeah, no problem. No problem. Yeah.
okay,
Yeah, you may
fantastic. Thank you,
continue.
thank you, doctor. So let's look into the types of GCs used in the oil and gas industry. Can I have the next slide? Yeah, thank you. So when we talk about GCs, I, what comes to mind is normally the conventional benchtop GC, which we see in the laboratory. It's mainly used in R&D or maybe in quality assurance labs or private labs, right? But there are also various variants or different variants of gas chromatography systems that are actually used in the oil and gas industry. Of course, we use the conventional benchtop GC, which is one of the most widely used GCs that we have. But we also have different variants such as the micro GC. Um, as you, they call it a micro GC because it's a much smaller setup compared to the conventional GC, and that's mainly because it doesn't have some of the parts, and especially it does not have a heated ejector, nor it has all the other peripherals like a very big heated oven, for example. So we remove the injector, and what's left is actually basically the heart of the system, which is actually a small heated oven with the column inside. So the samples that are actually fed to these kind of micro GCs are mainly gaseous samples. So when we say gaseous samples, so hence these samples don't really need to be volatilized. So you really don't need that heated injector, for example. So you can just feed the natural gas sample into the system straight away, and you can actually get the analysis done. But nowadays things are very sophisticated, very canggih. So back in the day, micro GCs, we used to plug it in using the RS232 port. Then they went to the RJ45 port, which is actually the LAN port. Now wireless technology kicks in, and um, you can actually hook it onto your iPad. They have apps for that, so you could be running an analysis in the lab, but you can be, for example, at your desk looking at your iPad and getting real-time data. So that's fantastic. Another variant for that would be a portable GC. So I've never had an experience using this before, but I have seen some surveyors going around with a portable GC, mainly The portable GC is actually used for in situ measurements, so you can actually bring this box into the refinery and have the analysis done in situ. And most of the time, these kind of systems are what we call explosion proof, because when you bring in electronic components or electronic devices or anything that has a heating system in it, uh, it's very dangerous because you are surrounded by pipes all around you that has hydrocarbon inside. And for example, if there's a leak, you imagine there's a leak, hydrocarbons get out, gas get out, for example, and if there's a heated system there, you know, it can explode. So there's a lot of safety features that are actually required for these kind of systems to be functioning in the refinery, for example. So one of which is to your far right, you could see a relatively weird looking setup. I think some of you might have seen this before. This is actually how an online gas chromatography system looks like. It looks nothing like the conventional benchtop system the laboratory. That's because it has been stripped down to its bare back parts and actually put into explosion proof systems. So that white box that you see in the center there is actually where the columns and the heated system is actually enclosed in or housed in. And there's a cutout there. If you can see, there's actually a screen, a touch screen there that you can actually press, and it can actually, that's where all the chromatograms actually, are displayed when they analyze the samples. So yes, so these are the various types of GCs that we use in the oil and gas industry. Can I have the next slide, please? Okay, so this slide, if I were to distill it down to the main points, um, I would actually say that the GCs that we have in a gas plant or in the refinery, they're not just one or two GCs that we use. We have rooms full of GCs, dedicated special rooms full of GCs. And depending on how large the refinery is or how large the gas plant is, you might be looking at between 20 to 60 GCs in a room. So that's a lot of GCs in a particular room. So that's because each and every one of these GC systems have a particular function. And you remember earlier on in the talk, I was mentioning that the refinery produces different types of products. So each one of these products has their own dedicated GC. This is because um, that we want to make sure that the analysis for these products actually have a high uptime and high reliability to them. So we dedicate a certain product to a certain GC. And this is also very good in a way that we avoid contamination. Sometimes you might want to be very, not sometimes, all the time, you have to be very careful about contamination, because that's where you get all these ghost peaks. You get this, peaks which you don't know what they are, start popping out, right? So by dedicating specific GCs towards specific products or specific hydrocarbon products, we are able to eliminate that to a certain extent. So what you feed into that GC is the same sample day in and day out. So if there's anything that goes wrong to with the system, you are able to actually capture it and troubleshoot it very fast. And also, there are certain types of products which we deem critical or mission critical products, which hook or by crook, that product has to leave the refinery at the same date and time that it's supposed to leave. And for those kind of products, we actually have a backup GC to the main GC. So you imagine they have the main GC, and just in case if anything happens, there's a backup GC. So sometimes this backup GC can share one or two different products, because it's not normally used every time. But the reason why we have these backup GCs is because that in the event that the main GC breaks down, there's a GC there directly for use, because we don't have to call the vendor, bring them in, troubleshoot, blah blah blah, and it just takes a lot of time, and we're going to miss the target deadline to release the products. And fun fact here, if you're a chemist dealing with gas chromatography systems, one of the skills that you really need to have is actually troubleshooting and problem solving skills. This really can be harnessed or developed through a lot of hands-on, which actually applies to different types of analyzers as well, not just the GC. The more hands-on you have on a particular analytical setup, the better you get. So it's one of the skill sets that employers actually want their chemists to actually have. So that's just a fun fact I threw in there, just to share. Can I have the next slide, please? So this is a schematic or animation showing how online gas chromatography system works at site. So you can see that in the top left corner there, it looks like a little house, right? So we call that an analyzer shelter. So in that shelter is where we house the components of the online GC. Um, on the outside there, you could actually see gas cylinders on the side, and that is actually where we house the carrier gas for the systems. As you know, GCs, we require inert gas. It's either you put in nitrogen or helium. You can use air, right? So that's why we have dedicated cylinder gases there for the systems. So these kind of systems actually function based on autonomous setup. So what it means there is that you can just leave the system there and it'll just give the results day in and day out continuously just measuring whatever components that you actually put into the system. So this particular setup is actually from a natural gas stream. So if you already have the sample in the form of a gas, hence you don't need to vaporize the sample, right? So that's why these setups don't normally have heated injectors. So the sample gas, as you can see in the animation from the process, actually passes through what we call a pre-treatment setup. A pre-treatment setup basically is a setup where it comprises of very fine filters and also like a knockout pot or condenser, because sometimes in the gas line you can have heavier components that we try to actually knock out through separation. And these samples actually enter what we call a sampling valve. Okay, so this line here, when it starts to go into the setup, is actually heated, but not to high temperatures, but just enough above the dew point of the hydrocarbon, so that whatever sample that actually gets fed into the system is in the form of a gas. So the valve will actually go in a sampling mode, capture the sample, and when it switches, what happens is that the carrier gas will actually translocate the captured sample into the column. Uh, the components get separated and then get detected. It gets balanced out, and also the data is actually fed directly to the laboratory and also the control center that we have at the refinery. So um, these kind of systems are very important in the oil and gas industry, because we have them in nearly all areas in the refinery, especially those with gas setups. Can I have the next slide, please? Okay, so still on the topic of online GCs, there are various setups available. Technology enhancement is fantastic these days. Uh, During my time when I first joined the oil and gas industry, things were very mechanical. But nowadays with sorry, tongue twister there. Digitalization, you get a lot of touchscreen setups. You get a lot of more sophisticated setups. So um, these setups again, they have different configurations whereby uh, some of them need to be enclosed in a explosion proof box, for example. And this in the oil and gas industry, we classify where these kind of setups need to be employed based on the hazardous zone classification. So we have 0 to 2, whereby 0 is an extremely hazardous area, where basically it means there's a potential of having hydrocarbon at any time. Then there's hazardous zone 1, which most of these systems are actually located. So hence we install them in explosion proof casings. So in the event that an explosion or short circuit happens, the explosion gets trapped in the box, right? So these boxes are very, very thick, very, very heavy, made of stainless steel metal. So, and they have automatic shut off systems as well. So if in the event that there's any problems, the system will automatically cut off by itself. Some of the other systems also use not just a explosion proof box, but a box which actually has a continuous purge of inert gas, so that the principle of that is basically in the event if there is any hydrocarbon leakage, because the box where these GCs are actually housed maintain a positive pressure, right? Because continuous flow of inert gas is coming in, so hydrocarbon from outside cannot come into the system and explode due to the electronics or the heating inside. So there are various types of approaches there, and The one on the far left is basically another form of how these GCs can be put together. Basically, just a skid mounted. Skid mounted means that it's actually just set up on a frame. This, in this case, is actually a back frame that we actually install at the refinery. Okay, so can I have the next slide? So still on the topic of online GCs, I took this example from Amazon. Amazon is also one of the industry, they make industrial GCs, online GCs for that matter. So the top left there, that's a picture of how the column assembly looks like. If you're wondering why does that setup look nothing at all like a GC, that's because, again, those components of the large benchtop GC has been stripped away, most of them, and just the bare necessities, which is the heart of the system, which is the column, is left there. So it comes in various configurations. I'm not going to go or delve into detail of all the configurations, but you can see in the right hand picture, the one on the top, it says shelter with one online GC, and the picture at the bottom, room shelter with multiple online GCs. So there are certain shelters or rooms that I mentioned earlier, which house these kind of GCs. Some of them only have one, but depending on the stream that they are measuring the sample from, they can actually have between 4 to 6 GCs, like the picture that you see at the bottom. So all of these GCs are online GCs are held or housed in a particular shelter. Sometimes this shelter is air conditioned. One of the reasons why we have them air conditioned is to maintain a positive pressure. Again, just in case there's a hydrocarbon leak from outside, it cannot enter the system and cannot enter the room. So due to the positive pressure that is being exerted. Can I have the next slide, please? So online GC is a fully integrated system. We love the online GC because the data or the raw information, sorry, the unprocessed data that you get can be checked by the lab. But of course, this information, because we have specific algorithms, specific software to actually process the data. So when we get the data or the signal from it is already processed. So this data can be directly fed to the refinery laboratory. That's where all the chemists are, and we can actually check the the status of each and every one of the products to see if they're on specification from the chromatogram. The signal also goes, or the data also goes to the control room. Most refineries have a control room. Basically, that's the heart of the operation. So that's where the engineers are. They will actually have screens there, and they also look at the quality. So once the chemists make sure that the product quality is on spec, calibration is done, carrier gas, no problem there, everything is done online, then they will actually have the product signed off. We have what we call a certificate of quality, COQ, that needs to be signed off. Fun fact here is that the COQ needs to be signed by a registered chemist, or in our case, IKM, Institute Kimia Malaysia, right? So you have to be the word is not registered, but you have to take you have to be a certified chemist to sign off. Not a normal chemist cannot sign it off, but you have to be a certified chemist to be able to sign off the COQ. So once this product is ready on spec, everything is okay, then we can ship out this product either to large ships like you see in the picture, or we send it through pipeline to the customer. Okay, can I have the next slide, please? So okay, one aspect of analysis or in analytical chemistry, which is very important, is validation. So don't trust anything that is online, no matter how well it might seem to work. So this is where we employ validation, cross-referencing and validation activities, whereby when we run the or obtain data from the online GC, we are also collecting manual samples from the line. This is done on a scheduled basis. We don't normally take as many samples as the online GC does. That's because we do validation or spot validation to ensure from time to time that the results that we obtain from the online GC and the GCs that we have in our laboratory are in good agreement with each other. So if they are in good agreement and they meet specification, everyone's happy. The chemist is happy, the engineer is happy, and we get to sell our products. So most important here is that the quality is maintained, and from an analytical standpoint, errors are really kept to a minimum. So can I have the next slide as well? So that brings me to the conclusion. Yeah, yep. Can I have the next slide? Okay, so basically what I've done here is distill the points of advantages and disadvantages of using a GC. I'm not going to go through all of them because I believe you can read them by on your own account. But the GC is, to summarize, is a wonderful, wonderful analytical tool that we use. It's capable of fast analysis. You don't really need a lot of sample to run a GC analysis. Depending on the type of column you're using, separation and also resolution can be very good. So that's where the knowledge of the chemist comes in. Uh, Depending on the setup as well, you are able to obtain high accuracy. Always remember to run a calibration and also a validation to ensure the system is actually working well. Sometimes signal drifts can happen and can occur. Disadvantages, yeah, GC, right? Limited to volatile samples. So those other samples that you can't really use for GC, there are other forms of chromatographic approaches you can use. Also, the GC and also chromatography in general can be hyphenated. We have a lot of other hyphenated setups that we have here in my research center. We have a pyrolysis setup, which is hyphenated with a GC. You can hyphenate it to another GC and to 2D GC. TOF, you can even hyphenate it to a mass spectrometer. So the combination is endless. So with that, can I have the final slide, which is the thank you slide? So before I take my leave, I would like to finish with this quote from Will Durant. Every science begins as a philosophy and ends as an art. So does the science of chromatography. It started off, if I'm not mistaken, with very simple and very primitive methods of separation, dyes, for example, or even chlorophyll. And look at where we are now with technology. 30 30 years, 50 years, 100 years to come. Very interesting to see what this technology can actually bring us and also make the world a better place. So that's all from me. If you have any questions, I'll be more than happy to answer. So these are my references, by the way, as well. Yeah.
Okay, thank you so much, Mr. Sharizal. Okay, I will say the presentation was very informative. Okay, I really enjoyed the way you present your whatever. Work that you are. You are carrying out that in your workplace. Okay, now I would like to request or open Q&A section for all the students here. Okay, you may start to ask Mr. Sharizal if you have any doubt, okay, about GC or today's lecture as well. Okay, so okay, class, maybe y'all can start the question. Just one moment, Mr. Sharizal. I think
Yeah, no
someone is,
worries, no worries,
yeah, they're turning on the
no
mic,
worries.
I think. Okay.
Yeah, yeah.
I think maybe
No,
Rahman, can you, yes, anyone here? Okay, Rahman, maybe can you ask some question? Uh, you can ask. Do you have any questions to ask to Mr. Sharizal?
Okay. I got one.
Ah, yeah, sure.
Okay. Like you are dealing with the hydrocarbon samples. It seems lots of impurities, right?
yes.
Maybe that mean through a day you run a lot of sample, so it going to be more downtime, right? How you handle it?
Well, that's a good question. Thank you, Mr. Rahman, for your
Yeah.
question. So the question is, uh, how do we manage to ensure high uptime of the GCs that we use when we know that we have contaminants coming into the system,
Yeah.
right? So
Yeah.
yeah, so for me, for most of the approaches that we have, I always subscribe to the notion of knowing is half the battle. So you have to know a little bit about your sample. So most of the time when we collect the samples, let's say for example it is from an offshore facility. Um, on top of having online GC or online systems at the refinery, there are multitudes of tests that we collect on a day-to-day basis from an offshore platform. For example, we check density, we check pH, we check composition, we check a lot of other tests. So when we collect the samples, to a certain extent, we have some prior knowledge that, okay, this sampling point or from this particular area, the contaminant might be high. So what do we need to do? Because we are interested to measure the composition of the hydrocarbons, right? That is in the line. We do not want to feed our GC with, for example, high contaminants. Some contaminants going into the GC fine, it just pops up as a peak there and you just ignore it. But certain contaminants like acid gases, hydrogen sulfide, CO2, for example, can be they can deteriorate the the column. So these columns are not cheap. So we run so many samples every day, and we want to make sure that the lifespan of these columns are maintained, or we want to extend it as long as we can. So prior to to running the sample, for example, we can check the online H2S analyzer, which is just before the sampling point, right? So before you collect the sample, check with the engineers. Can I have the data for the H2S concentration for the past 1 hour or so? So you can check. Let's say if it's high. So if it's high, you can collect the sample. Let's say you collect a sample into a high pressure sampling cylinder. You bring it back to the lab, but don't necessarily inject it straight into the GC. Excuse me. So normally what you can do is that you can actually put a trap prior towards the sampling valve. And this trap can be an absorbent which can actually absorb hydrogen sulfide if the target contaminant is hydrogen sulfide. So when you open the valve of the sampling assembly, the gas passes through the absorbent, right? So whatever contaminant, in this case is H2S, gets trapped onto the absorbent, and only the clean hydrocarbon gets passed through into the sampling valve and then injected into the GC. So these are some of the approaches that we use to actually handle contamination of our GC systems. I'm not saying that it has not happened. It has happened before, especially when it happens offshore. It's not that you can just hop into the car and go to the shop and buy the column. You are kilometers away from land, right? Sometimes one day by boat, sometimes 6 hours, 3-4 hours by helicopter. So these are the things that a chemist needs to be very very sensitive about. And yeah, so basically that's a little bit of how we actually handle these kind of situations lah. I hope I answered your question, Cik Rahman.
One more question.
Mhm.
I prefer to ask you about in situ situation scenario.
Mhm.
You in situ, you are in the at what at sea.
Mhm.
There are no stability. They are shaking there. How you put your instrument to on the place? How you handle it, manage it?
Okay. So your question is because we are at sea, right? So how we when we do analysis, for example, how do we ensure that we keep the setup stable? Because let's say if you're doing measurement with a microbalance, right? You know, some movement can actually cause it to be erroneous in terms of measurement, right? That's the question you're asking, right? Is that so?
Yeah. I think
Yeah.
yes.
Yeah,
Okay.
yeah,
Sure.
yeah. Correct,
Yeah.
correct. Yes, yes.
Excuse me. So, honestly, if you're on an offshore facility, offshore platform, if you see in the news or you see in National Geographic, those are really large structures which are very very stable. There are various forms of platforms. Some of them with the leg, we call it jacket leg, which is grounded to the seabed or the seafloor. Some of them are floating, but due to the sheer structure, huge size of the structure is very stable. So if you do your analysis on board, fine, no problem. Shaking, unless there's really bad weather outside, then you might feel a little bit of shake from time to time, but it doesn't really affect the instruments. However, if you are on a boat different story. Some of the boats are equipped with a small room which we convert into a laboratory. Sometimes they do surveys, right? That one a little bit more trickier. So no matter what you use to stabilize your equipment, let's say if you want to do you want to use a microbalance, right? Microbalance normally we put on top of that slab, you know, that slab, so that it's very stable. So even in if the seas are rough, right, the whole vessel will move. So when it moves, it will affect the the position of your microbalance, and there's nothing much you can do about it lah. So you have to wait until the seas come down, and when it's stable, and you can actually perform the measurement, then you can do the measurement. But most of the time the laboratories or testing facilities is actually located on the platform, and most of the analytical setup that we have at the platform are not like as complicated like the ones we have at the laboratory. That's why the GC we have like we don't have a full benchtop GC. We use like micro GC, we have portable GC, everything is compact and chomel, so it's easier to bring around. Is less prone or less sensitive as compared to a larger system. So these are the some of the tricks and also ways that we actually handle these kind of samples lah, or this kind of
All
situations,
right.
that is. Yeah.
Okay. Okay. Thank you.
Yeah.
Okay, Mr. Sharizal, I think we have another one from Muhammad Faris. So, maybe you can introduce yourself to Mr. Sharizal, then you can ask your question.
Assalamualaikum, Mr. Sharizal. This is Faris.
Hi Faris, yes.
Okay, I have maybe a few questions. The first question maybe to add to Encik Rahman. So the crude oil or hydrocarbon sample is normally a dirty sample. So maybe at some time when you run through GC, maybe the iron source is already dirty.
Mm,
So
mm,
you said earlier that the chemists at Petronas need to have a troubleshooting skills.
mm,
So how you the chemists here change iron source by themselves, or you have a maintenance through the engineer? That was the first question. So
mm,
the second and third question may be out of the context, but
mm,
I hope this is question hit you. Okay, the second question is I think I've been to two or three plants of Petronas. One is
mm,
chemical ethylene at Terengganu,
mm,
chemical entity at Kuantan. So I saw a quite I think mostly this specific brand of gas chromatography. So is this brand is actually affect the what called efficiency at the process? And the third one maybe at the Petronas Research Center at Bangi. So it's mostly about the research of the new technology, right?
mm,
Right.
mm.
New
Yes,
technology,
yes, yes, yes.
maybe the development of the process. So what is actually the process or development that they apply to the gas chromatography? And that's all.
Oh, okay, all right.
Okay.
On GC. Okay, thank you very much for excuse me, a string of questions. So let's start with the first one. I think the first question really has to do with training. When we have new recruits, or when we welcome in new chemists or new technicians for that matter, we